Hello, everybody. My name is Victor Cam. I work with the ArtEngine team inside of Unity. And what we're going to be doing today is I'm going to take you through a handful of scenes that I've built inside of Unity. And I'm going to talk about how ArtEngine really kind of helped speed up my art creation workflow. So we're first going to start off with the cursed runes in the scene over here. So we're going to talk about some unreleased nodes in this scene. So we use something called mesh nodes, which is, so we're still working in progress. I'm going to talk about how I decimated a lot of these hand sculpts and actually imported them directly inside of Unity. And then we're going to jump over to this urban exploration environment, where we're going to talk about another unreleased feature, which is the AI neural net material generation nodes. And what this is essentially you're taking single photos and building materials out of them based off of machine learning. So all the materials in here were built using single image to material workflows. And I'm also going to touch a little bit upon a little bit of speed tree and how chrome ball photometry works for the foliage. And then we're lastly going to finish off with this working from GNOME scene is what I call it. And this really just kind of ties everything in together, where we use a bunch of mesh nodes. We use also a bit of photogrammetry. More specifically, I'm going to go over just some basic workflows inside of ArtEngine, more specifically on how the soil was taken from a photogrammetry scan and then extracted into a tileable material for use inside of Unity. So without further ado, we're going to start off jumping back into our Unity scene. So this is the Cursed Runes scene. And we're going to talk about basically this head model over here. And every asset in this scene was actually hand sculpted. As an artist, like I love sculpting, I love using the tablet, and I love kind of just chipping away at things without worrying about topology. So this is what I'm going to show you guys today really is like a conceptual workflow. It's really good for rapid iteration, just to kind of get things automated into your game engine so you can quickly evaluate the art without really spending too much overhead and time and nitpicking with polygons and unwrapping things by hand. So I'm going to take another step back a little bit further to show you some of the source models that I used first. So I'm going to jump into 3D Coat. So if you haven't used this tool, this is a voxel sculpting software. So I've gone ahead and kind of just sculpted all these models by hand. So the thing is, when you're working with sculpts, if you kind of look at the wireframes over here, these things are really, really dense, especially if you're working with a voxelized workflow, right? So I think this one right here is about sitting at 11 million triangles, which is definitely way too high to use in a real-time environment. So I've also sculpted some of these other ruined pieces, like a pillar over here, and a couple other structural elements that we brought into that scene. So when you're working with this type of workflow, you generally have to go and either hand retopple these things and then hand unwrap them and then bake them down and then start to add materials on there. So what you generally will do is, well, you export this to like another application, decimate it down, or of course you can decimate them down in your sculpting software. But with the introduction of mesh nodes inside of ArtEngine now, as an artist, what I can do is I can do a single export of my high poly and then do all that work directly inside of ArtEngine. So I'm going to go ahead and just close this down, and I'm going to jump directly into ArtEngine. And I'm just going to show you a few of the nodes that I use to kind of work with these sculpts. So what I'm showing you right now, again, this is unreleased. We're still kind of working with the nodes and just making sure that things are going to work well, and seeing what type of artists are going to use these type of workflows. So I have the model imported directly into my graph over here. So this is about 11 million polygons. And if we look at the wireframes, this is what it is over here. The new node that we're introducing is called the mesh reduce node. And what that's going to do is going to allow me to pick a target poly count or vert count to essentially decimate this down to, right? And I've chosen about 10,000 verts because I still want to maintain a lot of the silhouette for my low poly. And what that's going to generate for me is something like this, right? And this is like a really, really quick decimated version of my high res model. And what I can do with this now is I can essentially just take all my sculpts into a nodal workflow and just reduce them, essentially bulk reduce these things into assets that I can drop into my game, because obviously an 11 million poly mesh is way too high for real time. So this mesh reduce node is what I used for essentially all the props in this scene over here. So they're taken down from millions of polygons down to, 10,000, 5,000, depending on the size of them, right? So when you do mesh reduction, of course, the other thing to actually be able to apply textures to them is we need to unwrap them, right? We need to add some UVs to them. So the next node that we're introducing is the UV generation node. And what this is going to do, and I'm just going to place the model over here like this, is what this is going to do is essentially unwrap your model in a quick and easy way, essentially. It's going to use something very similar to like an auto unwrap or a smart UV project, and then kind of pack all the islands as tight as they can. Of course, this is, when you look at how many UV shells on here, this is obviously not ideal for full production quality, but when you're working with rapid iteration, you're just trying to get something in the game engine that your art director can look at really quickly. This is definitely a really, really quick and easy way to kind of get things, get things in the game engine for you to evaluate. So if I kind of just place a texture on this, you can see that this is unwrapped with very, very minimal stretching right away, right? So when you're working with high res data now, you can actually just drop your mesh directly into ArtEngine, probably reduce it, and then generate UVs out of that, right? So, what's the next step for this, right? How do I actually make this thing like look cool now that I've reduced most of it, right? So what that's actually going to do is we have our high poly over here again. We've reduced it, and then we've generated UVs with it. So that's essentially going to be our game res version that we're going to put inside of Unity. And if you kind of notice over here, when we actually look at the model, it looks really kind of not that good, right? Because we've reduced it from 11 million to about 10,000, and obviously it's not going to look as high fidelity. So that's where obviously the baker is going to come into play. So now that we have a baker directly inside of ArtEngine, I can now use my high poly as the source, and then our mesh reduced and UV generated version as our target, and then actually bake down the maps. And what that's going to allow me to do is once I reapply the bake down textures, hey, this actually looks very close to the initial sculpt that I already had, because I have the normal maps baked out, I have the ambient occlusion, and I'm just using the curvature map right now as the albedo. So something like this with everything applied versus something like this, which is no textures applied or nothing baked down. So having this workflow inside of ArtEngine, it allows me as an artist who loves to sculpt, and I don't like retoppling stuff, and I don't like doing UVs, I can literally just drop that in here, and with these handful of nodes, I can really quickly get a game res version that I can start to put into Unity. So this is really, really fun way to work, and you don't really have to think about all the technical limitations that you have to do while you're freely sculpting your assets. So the next thing to do is actually, okay, well, how do I actually get some textures on this thing, right? So I'm gonna go and just grab a stone texture like this. And of course, this is not tiled, so I did download this from a public library of textures. And what I'm going to do next is I'm just going to put this through a mutation node. And what the mutation node will do is essentially it will use the AI algorithm to make it tileable. And I've also kind of just scaled it so it's a lot more dense in terms of textile density. That way I can wrap it around this large model, because this head model is quite big and insane. So when I put this onto the model like this, for those of you who have done a lot of unwrapping before, you're obviously going to know that you're going to see a lot of these like little seams over here. So you can't see one over there, you can see one on the side of the head, and then kind of like one on the back over here. And that's because the UV shells were essentially just exploded, right? And when material is going to cross the UV shells, you're going to get that hard cut. So the next node that we're going to introduce is the triplanar node. And this is very similar to using a triplanar projection directly on your shader inside of Unity, except this time when we feed it the mesh, like I have over here, and its texture set, we can actually just bake down the triplanar onto the texture itself, essentially. So you can kind of see what's going on up here, but it's actually wrapping around the entire model now. And if we kind of look at the before over here, so you kind of get these seams over here, and then after triplanar projection, it just essentially just removes all those seams, because it's doing a kind of like a box mapping with blending between the axes, right? So this is a really useful tool if you're using this type of workflow where you're sculpting things, decimating them down, and you need to kind of put a texture on top of it without having to worry about seams. So really right now we're just focused on getting something really quick, because we're focusing on rapid iteration. So using these new nodes, the mesh reduce, UV generation, and the triplanar node, I was essentially able to texture this entire scene on these models, these sculpted models, using these 3 nodes. So just to kind of show you a bit more of an end product, how I created the final texture for this is I use the diffuse or the color map from the triplanar, and then I just generated a normal map from that. So just using some shape from shading model, blended that back onto the original normal map like this. That way I can kind of get some really cool kind of like smaller bumps as the light hits the sides of it. And then for the color map, all I did was I essentially blended in the curvature map on top of the original rock texture. And that's going to kind of just pop some of my edges out like that. And then we just generate a roughness map from that as well too, just kind of give it a bit of a nice shine to it. And so that's in a nutshell kind of how I worked on the texture for the heads over here. So I've kind of zoomed right over here. It's similar to that. So that's kind of the workflow I did there. I did do some extra blends over here on the tops and the crevices as well for some moss growing and such. But essentially, this is the workflow that I went through to texture all the models there. So for me, having these mesh nodes is awesome because I love working with high poly stuff, and just being able to kind of do this all in a really quick node graph really helps me kind of speed up my workflow as an artist. So what I'm showing you right now is like, of course, you might not want to hand sculpt everything. Like I love sculpting things. You might not like doing that. So if you're working with photogrammetry data, a lot of people are doing a lot of scans now of objects as well. This type of node tree is also very useful. And I'm going to show you what I mean here. So what I have over here is we have a statue. So this statue is about 200,000 polys. And what I've done over here, excuse the mess of nodes here, I'm actually generating 3 different LOD versions of that mesh. So we have one that's about 10,000 verts over here, and then 5,000, and then 2,500 over here. So if we kind of view this in the scene, and if we kind of just put a solid color to that, and let me just turn on the wireframe so we can see what's going on. So this is the 10,000 verts, and then we can do, this one's about 5,000 and 2,500. So essentially I'm creating 3 different LED versions of that same model. And then of course, once everything's kind of like baked out, this is where you kind of start to regain your data back because you're doing the bakes on the normal map and the color map and such like that. So again, if you're working with photogrammetry data and you're not sculpting things, this node chain is going to be really, really useful for you to kind of speed up your workflow and kind of getting something like essentially auto game ready to kind of put inside of Unity, which is really awesome. So this is something that I'm really, really excited to get my hands on and kind of play around with. So it's really, really fun as an artist to not really think about these technical limitations as you're kind of working, either scanning things or sculpting. So with that said, we're going to take a step back and then we're going to jump into another scene. All right, so the next scene we're going to look at is something what I call Urbex Life or Urban Exploration Life. So this is the scene that we're going to be looking at next. And essentially the nodes that we're going to be talking about in this section is the AI neural net material generation. So if we look at all the surfaces over here, like the ground, the wall, and the bricks, and some of the wood over here, these were all generated from our single image AI-based material generation node. And I'm going to show you some examples from that and how that actually works, essentially. This is a really great workflow if you're using a capture device like a phone or an SLR just to capture single photos. Now we can actually use training data to build normal maps from that. So it's a really, really cool way to get good quality results without having too much overhead of capturing, like a photogrammetry data, essentially. So for our first example, I'm going to actually focus a little bit more on the ground debris texture over here. So I'm going to jump directly into ArtEngine again. So this is the source texture that I'm going to be working with. And again, we always talk about how things are not tileable in the real world. So this is obviously not tileable yet. And also we don't have any other PBR maps with that. Like we don't have the normal map, we don't have the height map, etc. So, when we talk about single image to material generation, like what is it exactly that we're talking about? The idea behind that is you take a single photo and you generate normal maps and other auxiliary maps for that. And typically the way that you normally would do it currently is or the kind of like the old like shape from shading method essentially, where it takes a lot of lumens values and creates height data from that. The thing is with this is you'll notice that there's tons and tons of sliders for you to kind of have to slide around and control to try to get something that's accurate to the real life material. As an artist, like I don't want to fiddle around with this type of stuff. I just want it to like know what it's doing and then give me a really good result. So you can kind of play around with these things, but even if you're a really good artist and you kind of know what these sliders mean, the result is probably not going to be as accurate as doing like a photogrammetry capture of this software. I mean, sorry, of the surface. So what I'm going to show you next is like, okay, let's put this through our neural net normal map generation node. So I'm going to jump down over here, and now you'll see this one here called normal generation AI based, right? So I'm going to put this single image again back into the AI, and this is the type of normal map that we get. And if you've seen as many normal maps as I have in my life, this is way, way cooler than this guy over here. So this one down here has a lot more, captured a lot more of the undulation from the ground, a lot more of the peaks and the valleys of the rocks. And this is going to give me like a really, really nice normal map, especially when I put it on a full material and roll the light across it, because that's going to be the most important. So the normal map training that we're doing essentially is based off of really, really high quality photogrammetry data that we're capturing in-house ourselves. And the way this works essentially is we take that photogrammetry data slash photometry data, and then we also synthetically relight it to mimic how someone would take a picture on an overcast day or on a bright sunny day from their phone. And then that essentially becomes our training set. So if you're kind of working in a way where you want to again capture things on the road without bringing a lot of gear with you, you have now the option to just take a picture from your phone and then pop it into the normal generation, the AI version of it, and get some really cool results from that. And again, you can be confident that this is actually trained off of photogrammetry data, so it's going to mimic the real world as closely as possible. So I'm going to just show you a few other examples of this thing in action over here. So we have some plaster and some brick, and I just put a normal intensity to it just so I can see the values a bit better over the video. So this is the type of normal map that you get. So you get some really good transitions from the plaster to the brick, and even like some of the grout kind of peeling away over there. Some wood. So this is some of the wood that I actually used in the scene. And get a really cool normal map from that as well. And this is another brick from the same scene that I was working on. And you get this really cool kind of brick material, brick normal map. Again, the grout is like really awesome, kind of spilling over the bricks as it would naturally. And this is actually capturing a lot of that because we've actually trained the data to understand how that actually, mimics in the real world. And lastly, just some broken concrete over here. Yeah, so it's a really, really good normal maps over here. This is really exciting for me as an artist because I don't really like to go out and scan things in the real world and taking like 200-300 photos to get good data out of it. I'd rather go and just quickly bring my phone or camera, take a quick snapshot, run it through this thing, knowing that it's actually going to be as close to photogrammetry as possible and give me a really good kind of data from that. So with that said, how did we actually use the other nodes inside of ArtEngine to make like a full material out of this? Because we only have the normal map over here, right? So let's go back to the rubble that I was showing you, or the debris surface. So on top of normal map generation, we're also training delighting as well too. This is still really, really early, but I did want to give you guys just a little bit of a sneak peek of it. So if we kind of look at this image here, we have some really, really bright whites over here, and you have some really, really dark occluded areas. So again, when we train this node with photogrammetry data, our photogrammetry is completely delit. So what that can do for us is actually delight these images really, really well as well too. So again, this is super early, but I thought I'd kind of show you the result from this. And usually what I like to do is I kind of like to do a blend of both, because I kind of like a little bit of baked lighting into some of my textures, but depends on the situation, right? So, with on top of the normal map generation with the AI one, we also have a bit of delighting in there. And let's go ahead and actually put this material together and kind of, see how it actually, how this thing was actually created. So taking these two nodes over here, so we have the DLit version, and then we have the normal map from the AI. The next thing I'm going to do is I'm going to just quickly generate a roughness map from the color map. And then from the normal, I'm going to generate a height map. And because my normal map is actually like pretty accurate to the training data, my height's actually gonna be pretty good too. So this is actually what I use to displace the geometry inside of the Unity scene. You'll see that it's actually the rocks and pebbles are actually coming off the surface because I'm actually displacing this in the engine. And from the height, I can generate an ambient occlusion map. So again, we're just getting the occlusion from the height data and using all that together. This gives me my full material over here. So let's check it out over here like this. So this is going to be my material, and we can just add a little bit of tessellation and just a bit of height to just kind of see how things are working. Like that. But of course, the next thing is, well, at the beginning of this segment, I did mention that this is not tileable yet, so I can't really use this in my scene just yet. So of course, this is where the seam removal node is going to come in. This is super easy to use. You just plug your material straight into the seam removal, and without doing any work, you kind of just have like a nicely tiled version of your texture there. So if we kind of double click on this guy, and I'm just going to change my surface so we can see it a bit better and increase the tiling. And my displacement's just a little bit too hot there, so I'm going to lower that down a bit. But then now we have pretty cool like tileable material. And that's essentially how I created the texture on the ground over here. So this same workflow essentially is what I did for the other textures and materials in the scene. So this guy over here, kind of going through the same node graph. So albedo generation, so a little bit of delighting, generating the normal map from AI, generating a roughness map, a height map, ambient occlusion, and then putting that into the seam removal. That's going to give me, a tileable version of that cracked concrete there. So again, kind of like looking at the plaster, this is how I worked on the plaster here. This is how I did the bricks and even the wood as well too. So this is going to be an upcoming feature. It's not in the product yet, but I'm super excited to kind of talk about it with you guys for the first time. And I'm hoping that it's going to help a lot of you artists who want some really good materials and just don't want to have the overhead of taking 200-300 photos for photogrammetry. So now you can just take single photos, use AI to build those materials. The next thing I want to talk about inside of this scene is the ivy over here. So these ivy bunches were created inside of SpeedTree, and the way that the textures were captured actually were used inside of ArtEngine, or sorry, were created inside of ArtEngine. And the way that we capture these is we use something called chrome ball photometry, or chrome ball capture is what people call it. And the way that you use this is you put your camera essentially on a tripod like this. This is just like a really cheap rig that you just put together with, this one is like 2 sticks with some tape kind of just taped on top. And you put your subject underneath it. And the key really is to put a shiny spherical object in your shot and then rotate a light around it. And you can take up to about 16 photos, I believe, to capture this. So the result of that is, so these are the shots that you're going to take. Right? So you're essentially rotating your flashlight around and snapping shots as you go. And once you're done that, you also want to include something called the mask map. So this is just essentially a black and white image that indicates where that spherical object was. And once you put that into ArtEngine, the chrome ball node is what we call it, you can generate essentially an albedo map and then a normal map. And you'll see that it captures the normal map really, really nicely because what this is actually doing is it's actually using the chrome ball to understand the lighting directions and then calculating that to generate your normal map information. So it's a really, really handy way if you don't have too much space for like a photometric stereo rig. This kind of opened up the door for me to build my own rig at home and capture some really cool surfaces. So to generate the full material that I have in the scene, I use the chrome ball node. And I just use a real simple color to mask to generate the opacity map. And this is what I get. And so this is the atlas that I have that I've used. So these are my ivy leaves that we've placed. And I'm just going to jump into SpeedTree real quick, and I can show you the ivy leaves exported into SpeedTree and what that model looks like. So using SpeedTree with ArtEngine's Chrome Ball, really, really awesome, because SpeedTree obviously is a foliage tool, and having Chrome Ball with SpeedTree can really kind of like help, you know, like allow you to kind of capture textures and such like that. So if you're familiar with SpeedTree, and I just kind of made my vines disappear there. So I'm still a little bit new to SpeedTree, so I think the SpeedTree folks are going to laugh at me kind of goofing up with this model over here, but SpeedTree is super awesome to be able to kind of create foliage really quickly. So using the Chrome Ball and SpeedTree, all I did was create this in here, export that directly into my scene like this. And then now I have these little clumps of ivy that I can use to kind of like decorate the scene. So that's going to be the AI material generation nodes that I wanted to show you with this scene. Again, really, really quick workflow to kind of get your materials looking good with single photos. And I think the next scene I'm going to jump into is the gnome scene. And this is kind of where we use everything together to build a full scene. All right, so in our last segment here, we're going to look at our scene called Working from Gnome. So I think everyone's been working from home for the last few years. And so even the gnomes had to work from home. So going through this scene over here, you know, we talked about mesh nodes, we talked about photogrammetry and kind of like AI-based material generation. So this scene essentially uses a combination of everything and some of the standard nodes inside of ArtEngine as well too. So kind of looking at the props over here, the gnome. So this was again hand sculpted. So I used the mesh nodes and auto unwrap and auto mesh decimation. That same goes the same with the door and the mushrooms here, and of course the snail. So these were all hand sculpted. This foliage down here, so these little clovers, these were captured using Chrome Ball, and then I just kind of modeled them inside of Maya and apply the textures to them in the scene. So instead, what we're going to do in this segment is we're going to actually look at the soil over here. So how was the soil created, right? And this is going to be more kind of aligned with people who are doing photogrammetry. So taking surface scans of, you know, taking about, you know, 100 to like 200 photos and processing them inside of reconstruction software. You know, how do we actually take that data and actually make it usable inside of a game engine? So let's go ahead and actually, you know, to make this a little bit more meaningful, let's replace the ground with something pink. And then, so just we know, like, hey, we got to make a texture for that, right? So what I did was I actually took my camera out and kind of went to one of the nearby parks, took about 30, 40 photos of it. And I put that into a tool called 3D Zephyr. So this is my preferred reconstruction software. I don't do this professionally. This is something I just do for fun. I really like the software and it's just easy for me to use. So I've kind of gone ahead and brought those images in here in this tool and reconstructed the surface. So this is the soil that I took and it's fully reconstructed in 3D with the texture. And generally when you're working with photogrammetry, you have to take the scan and then bring it to another 3D modeling application to build like a flat surface on top of it. That way you can project your data for the bake essentially, right? Or something called a baking plane. As an artist, like I absolutely dread doing that. It's not a fun task, but you kind of have to do it. So what we've introduced inside of ArtEngine in the past few months is something called the plane generator, which will automatically do this for you inside of the graph. So let's go ahead and just see this thing in action, right? So what I've done already is I've exported this model along with this texture, and I've placed that right into the graph again here. So I just brought that thing straight into ArtEngine. This one is about, I would say about 4 million polygons. It's not too high. And then what I'm going to do is I'm going to run it through the plane generator node. And what this tool is going to actually do for you is it's going to reproject a flat surface to the mid-level of your source data. Our source data in this case being the soil, the scanned soil that I have. So this is going to actually act as your baking plane now to rip off that data from the high poly, so then we can actually make it into a tileable material essentially. I'm going to go down a little bit in the graph, and I have this set up. So this is the way that you'd want to set it up: is you have your high poly from your reconstruction software. You have that connected to the plane generator tool, and of course, you also want to input your texture from the reconstruction. And then that all feeds into the baker. Okay, so obviously the baker is going to house a lot of the operations that we do when we're kind of downsizing things for game engine, right? So with all these things kind of hooked up, let's just see what this thing baked out for us. So this is what it baked out. Okay, so you can see a lot of that extra data over here is missing. So we're actually missing a lot of stuff that we didn't capture. Again, I didn't really capture too big of an area. I think this is only about like 1 meter by 1 meter. But we have all the data baked out: your height map, ambient occlusion, and normal map. And the next thing that I'm going to do is I just put a normal flip in here, just because sometimes when you use the plane generator tool, it comes out as DirectX. So depending on which normal map format you're using, I'm using OpenGL for Unity. I just put a normal flip in here just to kind of get that corrected. I'm going to generate a roughness map again from the color, and I'm going to put that into a composed material like this. So let's check it out in the 3D window. All right. So as it stands, like straight off the bake, this obviously does not look usable at all, right? So there's still quite a lot of work that needs to get kind of done over here. So we definitely need to fill in these sections over here. So this is where a lot of the cool like AI stuff is going to kind of help you out with like problems like this. So I'm actually going to use a tool here called the mutation node. Okay, so the mutation node is, I would say, like the Uber ArtEngine node. If you look at the parameters, there's a ton of parameters in here. So you have world scale, scale and orientation, seam borders, and just like a bunch of other jitter amounts up here, and also output dimensions too. So what I need to do with this is we're trying to solve a couple of problems here, right? The first problem is we need to fill in those blank areas of dead space that got captured essentially. So what I'm going to do is I'm going to take the ambient occlusion map, and I'm actually going to, so the ambient occlusion map is this one over here. And I'm going to put that through a levels node, and I'm going to actually invert that and just crunch the values down. So what this is going to do, it's going to, the white areas are going to tell the algorithm to, hey, ignore these areas and fill it in with synthetic data. That's what that's going to do. Okay. So I'm going to take this and put it into this little slot here called the ignore section. And the next problem that we need to try to solve is, oh, this is already fixed. So let's go back here. The next problem that we need to fix is I don't know the scale of this actual capture. So in terms of you're working with texel density, you either want like 2 meter for every 2K map or 1 meter for every 1K, depending on what type of engine you're working with. So what I'm actually going to do here is use the world scale parameter, and I'm going to use the input and output. So what this is going to allow me to do is it's going to allow me to go, hey, what was your original dimensions that you captured at? So I know I captured about 1 meter by 1 meter, and then what's the target dimension that you want to go to in real world scale? And I'm going to do this to about like 1.5, so 1.5 meters or so. So with these two things set, so world scale and the ignore, if I execute the mutation node, you'll see that, hey, check that out. It essentially just filled in all the gaps there, all the data with synthetic data or AI-based like data. So it's actually taking a lot of that information and filling in for you because we have this thing here called the ignore mask. And this does work across all channels of your material. So it's a really, really quick way to like just patch up certain areas of your data that's like not really working for you. And if you aren't familiar with the mutation node, what it's doing, you can turn on the preview button over here. And what this will do is essentially create a lower res version of the result. And the cool thing about this is you'll notice that if I start to kind of slide these around like this, there you go, it's generating the preview. You'll see it's actually kind of like jumbling it up. So I'm gonna hit new seed. And it's just processing right now. So it's generating preview. And so what this is actually doing, it's actually taking your sample, pasting it around, and then it's kind of synthetically stitching them together. So what you can do with this node is you can actually, with all these parameters, create pretty much infinite varieties of your material with just like a few handful of sliders. And the preview is taking a little bit longer today, but usually it's a lot quicker than that because I have a lot of other windows open. But you'll see it kind of created another version over here too, right? So this preview version, preview window is actually really useful if you're trying to understand how the mutation node works and just like trying to fine tune your variations. So I just wanted to show you that because not many people know how to use that one. But let's go back to finishing off this material. So we have it fully tileable now, but I can see there's these leaves that are still repeating in the full material. So I'm going to go ahead and just use mask paint, just scrub over those sections, and we're going to put that through a content aware fill. And that's going to just kind of get rid of those for me, right? So the content aware fill is a little bit different than other ones, where this one actually works over the entire material. So it's a pretty cool tool. So we have there we go. So now there's no more leaves there. That's looking pretty cool. So the next thing that we can do as a Unity user, obviously, like how do I get this stuff into the game engine, right? If I don't have a Unity scene open, what I can do is actually right click and choose view in HDRP view. And what this will do is actually open up another window. This is actually a Unity HDRP scene. And what I can do with this is essentially just kind of go through different lighting environments, change different primitives. And I usually like to use the sphere and just kind of check it out like this. So this is a kind of a cool way to just preview your work. I usually dock this on my second monitor. So if I don't have a Unity window open or a Unity project open just yet, I can check it out in here first before I create a new scene. So you can just kind of close that one down. And then the last thing that we're going to look at is the Unity direct link. So all the scenes that I've done, so all the work from the first scene, the Cursed Ruins, to the Urbex life scene, to this scene, all utilizes the Unity direct link. And the way that this works is you choose Unity direct link, you put the path directly pointed towards your project into your materials folder, essentially. And you choose your render pipeline. So I'm going to choose HDRP lit, and I'm just going to hit export. And what this is going to do, it's going to convert your roughness map into a smoothness map. It's going to make the mask map for you. And then on the Unity end, it's also going to apply the proper sRGB flags to the correct textures, and then create the material. You can see it's doing it right now. So it's ingesting it. It's going to create the material like this and assign everything to it, right? So really, without really knowing how to put a material together, you can literally just use the Unity direct link, and then you have a material that I can drag and drop into my scene like this. So this has saved me probably hours and hours of time kind of dragging and dropping my bitmaps into here and kind of going through the old process of create and then choose material and then naming it something and then having to assign all these things individually. So the Unity direct link, if you're a Unity user, this definitely will benefit you to really quickly getting your materials across into Unity, into a usable state. So that's definitely the last feature that I wanted to talk about today. I think the other thing that I want to mention before signing off is that if you notice that everything that I showed you today lives in one graph, from the Cursed Ruins materials to the Urbex materials to the working from GNOME stuff. And why I'm mentioning this is because if you're a smaller dev team with a smaller art team, I don't have to manage a bunch of files for each material. If I work solo, like all these scenes that I've shown you, I've worked on these solo. So like for me to kind of work on these and having to manage a bunch of files can take a lot of bit of time. So actually all the scenes that I've shown you today each of them have only one Art Engine file associated with them. So all these materials live in that one file, and I can kind of go back and kind of like compare material to material for that one given scene. So just a bit of organization stuff there. It's pretty cool to be able to do that inside of Art Engine. So with that said, that's all I really wanted to talk about today with Art Engine. I kind of give you guys a heads up of what we're working on the back end, the mesh nodes, the neural net material generation nodes, and obviously the Chrome ball. It's super cool and fun to play around with. And we also have a ton of other nodes inside of Art Engine, like the mutation, the plane generator tool, the baker. I've only really scratched the surface today of what's in there. So definitely check out, the Unity product page for Art Engine, or YouTube, or just see what's also out there in terms of tools, because there's a lot more that I didn't really talk about today, but I think that should be good enough. And if you didn't know about Art Engine, I hope you do now. So thank you so much, and I'll see you guys next time.